Hey, folks, we're about to start here, so we please get folks in from the bar and also fill in here. It looks like we're filled, but any missing seats, fill out, and then if you need to, roll into the back. We're going to start in about a minute here. If we can really get people to settle down, it'd be great. Thanks.
Hey everyone, how's it going? Woo! All right. Welcome to Capgemini's Applied Innovation Exchange. I am Brady Campbell. I am the program manager here. I've been with Capgemini for about 2 years now, and I think this is Pete and my's 8th What's Now that we've done together. How many people, this is your first time at we call it the AIE? Raise your hands. Awesome, awesome. Love seeing some new faces, love seeing some veterans to What's Now. Thanks for coming. What's Now is an event series that we've been hosting for about 4 years now, and it's really our way to connect and kind of cultivate relationships with the startup, innovation, ecosystem, and community in the Bay Area. At Capgemini, we bring clients from all over the world who are curious to connect with entrepreneurs, thought leaders, innovators like Liz Specht, politicians, corporates who are really kind of setting the pace of change in society and things that are really going to have an impact on us in the future. So when Pete and I were talking about what topic we were going to kick off a new decade of What's Now with, the future of food seemed incredibly appropriate. Hopefully everyone picked up on the fact that the food tonight was all plant-based. That was very intentional. Hope you enjoyed it. And I'd also like to say, let's give a round of applause for Hooray Foods, who was here serving, hooray, yeah. Let's give a hooray for them. Serving plant-based bacon. And I know there's other food innovators in the audience as well, so I hope you will engage and speak up. I myself went completely plant-based on January 1st, and yeah, it's awesome, thanks. So yeah, I'm just really excited to have you guys here tonight to have this conversation. I have to give one shout out. My mom and dad are watching the live stream in North Carolina. Hey, Mom and Dad. We live stream this for a reason, right? So thanks again for being here. And Pete, over to you.
Thank you. Thank you, Brady. And thanks, Capgemini. I always want to put this forward. I'm the host, Pete Leiden here, and I run the media company Reinvent, and been working on this for 5 years. Actually, we are in our 4th year, but we're entering in the spring our 5th year here. If we finish this year as planned, we'll have done 50 of these, 50 events. And none of that would have been possible without Capgemini generously saying they're going to help feed the commons here. Because when they came and opened this space 5 years ago, they were kind of saying, they approached me and they said, hey, what can we do with this great space? What can we do for the community? What's missing in this crew, in this Bay Area? And I said, you know, one of the things that's missing is a way to actually cross-connect all the innovators from all these different areas, all these different fields, and all these different sectors of the economy, because so much innovation is you kind of get focused in your own little world and you kind of don't understand what's going next to it. So they said, let's do that. And so we've been taking 50 times almost, or we're in there close to 50th now. Get here and in New York, by the way, we're also expanding there. We're taking someone who really gets a space, like our speaker tonight, who can come and explain to a very sophisticated audience outside that field what is really going on now in that space, what's coming, and what you should really start to wrap your head around in that space and as it impacting the future. And so, like I say, we have been doing this for these years, and we've kind of focused, since it's a tech-based thing, there's been kind of 3 categories of what I would call like meta technologies. There's a kind of the digital revolution extension, the kind of information technology future, which is AI and advanced computing and where that's kind of going. We've done quite a few. What's now is flushing out that future. There's also the kind of energy technology future. And we've done a lot around climate change and all the different things, including electric mobility a year ago here, if you remember. And so we've kind of been flushing out that space of technology. But one of the spaces we really haven't done as much on is what I would call biological engineering, synthetic biology, or some people just call it biotech. Now, we have done some of that. About a year ago, we had Linda Avey from 23andMe about the whole revolution in genome, kind of the cost crashing in genome. But we haven't really pushed it hard enough. And so what I've kind of done in the last 6 months, I'll just kind of give you a little orientation here. I've been working on a piece I'm working on for Wired Magazine on the next 30 years of what's going to happen in the next 30 years and how we could possibly solve climate change and a lot of these big challenges facing us, income inequality, political polarization. I got my hands full, I'll tell you. But that piece, I interviewed 25 people to help me kind of flush out what is going to happen in these next 30 years. And I needed people in all these three meta tech sectors to kind of help think through what's going to come in the next 10 years, 20 years, 2030, 2040, 2050. And when it came to synthetic biology, this kind of revolution essentially in biological engineering, I was told you should talk to Liz Beck. And so one of the 25 interviews I did was with her, and I'll tell you, it really, out of all 25, it was one of the most fascinating conversations I had. It totally expanded my brain on what's possible in this space. And she is essentially, so I thought, heck, if she expanded my brain like that, I'm going to have her come and expand your brains today. So that's why we brought her here today. And so we have got a treat tonight, I would say. Because when you really get this revolution is really the least understood of the technology revolutions in the Bay Area here. A lot of us know infotech, a lot of us know energy tech. Most people, unless you got some kind of expertise in that area, don't really get how deep a change and how fundamental a shift that we're walking into here. We're essentially taking all living organisms and being able to engineer them, optimize them, do things that we never could have done before, and we're on the verge of doing that in all kinds of fields, in food, in materials, in energy, and all kinds of things which we're going to talk about today. And so Liz is going to start talking to us, though, through the lens of the future of food, of physical things of food. Primarily, she's going to be talking about it through the future of artificial meat, which is just breaking out now, but is going to grow gangbusters in the next decade and beyond that. And so she is going to help walk us through this, through that lens, into the bigger kind of lens of synthetic biology. And the reason she's so good at this is she's the Associate Director of Science and Technology at the Good Food Institute. And this is a nonprofit that is essentially trying to figure out the pioneer and the new way forward in this and help connect up all the groups, insiders in the industry, startups outside the industry, activists, all kinds of folks to kind of think about how are we going to actually scale this up in a way, particularly to actually deal with the profound changes with climate change. She's going to talk to you a little bit more about what they do. I don't have to say much more about that. She's going to do a little presentation for about 20 minutes, lay the land, open to kind of lay the foundation. I'm going to then interview her for a while in front of you folks, and then we're going to roll into interaction with all of you in the conversation. As always, we want to leverage the brain power of the network, who is cross-disciplinary network that we've gathered here. So with that, let's welcome Liz and start the evening. Come on in.
Thank you, Pete. Wow, some high expectations here. Hopefully I don't disappoint. See if we can get some slides here. Great. It's a pleasure to be with you all tonight. This is a topic that is eminently relatable to everyone, and I love when we have the opportunity to showcase some of these newer products coming out. We had Just Egg in the frittata there, the bacon that Pete mentioned. If you're in the Bay Area, or even if you're across the country, or frankly now anywhere in the globe, you'd have to be living in a hole not to notice this whole wave of new plant-based products coming on market, all of the innovations that we're seeing here. So this topic is very fun and tasty and here and now, but also has really, really deep sort of technology roots to it as well, which makes it exciting to me from a very nerdy perspective. As Pete mentioned, I'm Associate Director of Science and Technology at the Good Food Institute. We are a nonprofit. We're running a little bit of a unique model here where we are nonprofit supporting for-profit innovators who are developing solutions to make behavior change, to make diet change, to make systemic change as easy for people as possible by having those sort of drop-in alternatives to products that they've grown up with and know and love. We tackle this through three main core programmatic areas. The first is science and technology, really landscaping what are the unknowns in this space, how can we draw insights from parallel fields and parallel technology sectors to address those needs. Then corporate engagement, engaging with the existing big food industry. We hear a lot about these younger startups, and they are very much moving the needle, but we need to encompass all of the incumbent players in this massive industry. And then finally, policy, so helping to sort of pave the way, opening up more government support for the activities going on here in recognition that this is very much related to overarching goals and government targets for things like climate and food security, frankly, as well. So this is the main question that really drives our work. How do we feed 10 billion mouths by the year 2050? Fast approaching. And not only how do we do it, how do we do so in a way that won't completely ransack the planet, that's not flagrantly wasteful of resources, and that doesn't compromise global health or public health and put us at severe threat? So there are a number of what I call mega trends happening right now in food and agriculture, and they really all do kind of piggyback off of each other to a large extent. We see a lot going on in digital agriculture, or some folks call precision agriculture. Those are kind of two sides of a similar coin. Can we be much more targeted about how we're growing our food, how we're applying various inputs to the system, rather than treating systems as sort of holistic, uniform plots of land, recognizing that there is actually a variability in all of these natural systems. Another area is trying to leverage biology at the level of the soil. So a lot of work going on in soil microbiome engineering, trying to leverage a lot of these symbioses and mutually beneficial relationships that naturally exist between plants and bacteria in the soil. A lot going on there. Of course, a lot happening in indoor agriculture and vertical farming, things like that, moving food production closer to urban centers, particularly for some of the more perishable foods, fruits, leafy greens, vegetables, berries, things like that. So exciting work happening there. But then my sort of true love is in this last box here, alternative proteins. So in this box, we're talking about alternatives to animal-derived protein that we sort of default to as our protein source, but this can entail a number of different production platforms that we'll go into in much greater detail in a moment. So what's happening in the alternative protein space? I want to start with a provocative statement, and hopefully in the next 15, 20 minutes, or if not, in the conversation that follows, maybe I'll be able to convince you that this might be true. So my provocative claim is in the year 2050, we won't eat animals anymore, but we'll still eat meat. Right? That's the future I want to see. So if you look at a graph like this, it seems like we're not doing so well on that goal. Oops, thank you. This is a trajectory to date of global meat consumption. These are all the different regions of the world. In every region, up and up and up. This only goes up to about 2014. This trend line is expected to continue, basically at this pace, for the next couple of decades. We're projected to need another 70% of meat by the year 2050. There's a number of reasons that we can't supply that through business as usual practices. I could talk about water use, I could talk about greenhouse gas emissions, I could take a number of different lenses here. I'm going to talk about land use because this one's kind of hard to argue with. We have one Earth, and that's about it. If you look at Earth's surface right now, of course, only about a third of it is land. About 75% of that or 71% of that is habitable, so basically not under glacier or not comprised of permafrost. We're already using 50% of that habitable land for agriculture. Of that land, 3/4 of that is used for livestock production. So that's either pasture land or range land that animals are grazing on, or that's land used to grow crops that is then fed to those animals. But if you look at where we get our protein calories, only about a third of our protein supply is coming from those animal-sourced proteins. So why this imbalance? Why are we using so much land to produce so little of our protein? And if you look at this, it's pretty clear we can't double our meat consumption unless we want to literally clear all the remaining forests. And we already see the implications of this in places like Brazil. If you were watching the news in recent months, the vast majority of that deforestation was to either clear pasture land or clear cropland for growing soy. So we see this manifesting every day and increasingly year after year. The reason for this imbalance really comes down to thermodynamics. I'm a chemical engineer by training. This is actually the reason that I first went vegetarian back in college. It rubbed me so raw that we have conversion efficiencies inherently built into animal agriculture that look like this. So for chicken, one of the most efficient species of animals from a feed conversion perspective, it's about 9 calories into a chicken to get about 1 consumable food calorie out. And that's because, like any living, breathing, metabolizing animal, they're burning off almost all of their intake energy to move around, pump blood through their veins, respire, maintain body temperature. Same with us. If you look at something like a cow, your conversion efficiency is about 3%. Imagine a system where we've got 97% food waste and how outraged people would be by that. That's the system we've got here, but it's sort of hidden. It's behind the scenes. It's not as visible as food waste in your household, right? So this is the challenge we're up against from an efficiency standpoint. But it's not just environmental impact, it's not just efficiency. There are also severe public health consequences from the way that we have industrialized and intensified animal agriculture, specifically for the purpose of trying to eke those conversion efficiencies up just a tiny bit. We've moved towards these very intensive kind of confined operations that require things like subtherapeutic antibiotic administration. So providing antibiotics to animals at doses below the dose at which you would be treating, say, an acute infection, and that is a perfect breeding ground for antibiotic resistance. Some think tanks estimate that by 2050, antimicrobial resistance will cause more deaths than cancer. So a really concerning looming trend. And antimicrobial resistance, I think, has gotten more play in the news, but I argue that's just the beginning. About 75% of all new pathogens in humans first emerge in animals and then make that zoonotic leap into humans. Some of you may recognize these sort of spacesuit-looking suits because this has been on the news a lot for coronavirus in China. These folks are dealing with pigs that have been infected with African swine fever virus. Different virus, exact same sort of etiology of how these types of viral variants emerge in animal contexts and ultimately make their way into human populations. And we hear these same warnings virtually every month. If you look in the news, you'll find headlines along these lines. If you want to save the planet, eat less meat. Animals are the next big antibiotic threat, et cetera. There's increasing awareness about this. People increasingly understand that our current system of meat production is problematic. And yet, we see this chart. We're still getting up and up and up increases in demand for meat. Until now, and I would argue in the last couple of years, we've really seen the first few signs of starting to be able to turn this around. And what's changed is sort of our framing of the problem. Our framing of the problem is no longer how do we get people to eat less meat, it's how do we make meat in a better way? How do we make something people want? This is the tagline for Y Combinator, of course, our sort of famed tech combinator or tech incubator here in the area. Make something people want. If you don't have a solution that people actually want, it's not going to gain traction. It's not going to catch on. And the way that the food industry has been interpreting this in the realm of meat alternatives is to make products like these, like the Beyond Sausage or the Impossible Burger, that look and taste and smell and have pack the same nutritional punch as meat, and really serve as that kind of one-to-one drop-in replacement. And these products really are going mainstream because that's their goal now. This is not just sort of a functional veggie burger that you throw on the grill and the vegetarian begrudgingly gnaws away at it during the barbecue. These are products that people genuinely want to go out and try, find really compelling. They feel good after they eat them. This is really a game changer here. And the reason we know that they're going mainstream is because they've broken out of that niche of catering to vegetarians and vegans. These are now products for everyone. And we see that borne out in the data from a lot of these companies, that the vast majority of the consumers of these products are not vegetarian or vegan. They are total mainstream omnivore consumers who are choosing to eat less meat at certain meals, but don't want to compromise on taste and experience. I could show 1,000 of these sort of extreme hockey stick curves in this field because really all of this activity, if we're being honest, has occurred in the last 3 years or so. This is in food service, so looking at restaurant chains here in the United States. You can see there was essentially nothing going on in the realm of these types of meat alternative products that are meant to mimic the experience of animal meat. Sure, you could find a veggie burger or a black bean patty, but not products like these. Until about 2017, we started to see uptick in the number of restaurants. And this growth chart doesn't reflect the number of restaurants that are interested. This reflects the scale at which these companies or the pace at which these companies can scale their manufacturing. They are constantly being bombarded by more demand than they can actually manufacture for. So we would actually see a sharper curve than this if this were based on demand. It's bottlenecked right now by manufacturing capacity. The same thing's happening in retail, and actually this curve looks even more absurd. So the last one was in restaurant chains. This is in retailers like your grocery store chain. This is the number of product launches. You can see we've sort of gratuitously put some of the older products here, like a Boker Burger or Morningstar Patty, which I should mention, I don't mean that disparagingly at all. These brands also have been upping their game in the last couple of years and really, again, trying to cater towards that more genuine sort of meat mimicry experience. But in the last year or year and a half, we've just seen off the charts numbers of product launches. What's fascinating about a number of these, if you recognize some of these brands, many of them are meat companies launching their own plant-based meat products. If that's not a resounding endorsement of where this industry is headed, I don't know what is. So it's a really exciting time here. And this is not just happening in the United States. That's where we have the best and easiest data, so that's what those last couple were reflecting, but this truly is happening globally. A lot of the innovation around product development is happening, as you might expect, in places like Europe, but also in some other places that you wouldn't necessarily expect. We're seeing the same trends happening even down in meat-loving Brazil and South America. We're seeing trends various places around Asia, even folks in Africa innovating in this category. So this truly is a global phenomenon. Now I want to talk about the technology. So we've talked about plant-based meat products. That's what you'll really see penetrating the market in a really visible way. But I want to take a step back and talk about the whole alternative protein universe or landscape from a production perspective for a moment. So when I'm looking at alternative proteins, I really kind of segment things into these three buckets. There's the plant-based realm. That's as straightforward as it sounds. We'll talk a little bit about some of the juicy technology areas behind the scenes there in a moment. Then there's a category that I call fermentation, which is using microbes to produce valuable ingredients that can contribute to these products. So by microbe, it could be yeast, it could be fungi, it even could be certain species of bacteria. Cultured foods and fermented foods are quite popular these days, so I think that terminology may scare people off less than it would have 5 years ago, perhaps, but there's a lot happening in this area. And then finally, using actual animal cell culture to make genuine meat. And this is an area that we call cultivated meat, or you may have heard called cultured meat or cell-based meat. Quite a few terms still being kind of debated by the industry here. So from the cost perspective and sort of an infrastructure perspective, this is a useful segmentation for the underlying technologies here. But when you're thinking of these actually making their way to a consumer in a product, they may leverage ingredients from multiple of these categories. So let's first define plant-based meat. Here we're talking about using plant-derived ingredients to make a structured food that has the exact same sensory experience, the taste, the mouthfeel, the texture of a meat product. So not talking about things like tofu or tempeh, but talking about things like the Impossible Burger and Beyond Sausage and so forth, intending to be those sort of drop-in replacements. Behind the scenes, what the production process for these looks like is starting from these raw materials, plant-based crops, typically land crops, but there are folks looking at things like using seaweed as a source material, for instance. Typically some degree of fractionating those crops. So often you're kind of enriching for the protein content there so that you can get these kind of fibrous structures in your final product. And then where we've seen kind of the most visible innovation happening in this area really is in this last box here of getting that structuring right, getting those plant proteins to really align in fibers that feel like muscle fibers and muscle tissue, and in the formulation. So playing with different flavoring ingredients, playing with different ways of getting the right kind of juiciness of the bite and the right fat content to recapitulate that consumer experience. So there's really room for innovation across all of these areas. This is not just sort of a playing around in the kitchen culinary sort of endeavor. There's a lot to improve upon here. In the fermentation space, as I mentioned, this includes cultivation of any microbial species, so any single-celled species. These could be microalgae, they could be bacteria, they could be yeast, they could be filamentous fungi. So if anyone's familiar with a product called corn, Q-U-O-R-N, that's a filamentous fungus, forms the primary kind of protein biomass of that product. And this is, frankly, pretty old school technology, but this is sort of a new application area. And you can use this platform to make a whole suite of different flavoring ingredients or pigments or aromatic compounds so that your product on the grill smells just like meat. Products sourced from fermentation can really run the gamut from sort of whole tissue products. This one all the way on the right-hand side here, or sorry, on your left, is from a new company in Colorado called Emergy. That's a filamentous fungus forming an actual, essentially, chicken breast mimic as a whole intact tissue-like product. Some of these in the middle here are using fermentation to make actual animal proteins without the animal involved. So companies like Perfect Day, Geltor, Clara Foods are making milk proteins like casein and whey, gelatin proteins, which is really collagen, and egg white proteins, respectively. So you take the exact sequence for those proteins that you know is a highly functional protein that works well in a lot of food applications, and you simply ask a yeast or a bacterium to serve as your production machinery for making massive quantities of that protein in a very scalable way. Companies like Impossible Foods, one of the reasons they're able to get that flavor so compelling is that they use a protein called a leg hemoglobin protein that they manufacture in a fungal-based platform that's really giving it literally that color of blood. It's carrying oxygen, just like heme in muscle tissue or in blood. And then finally, there's cultivated meat. So this is growing genuine animal meat without the animal. So growing it from the level of the cell. Imagine farming the cell rather than farming the whole animal. If you think about what meat is, really it's just a collection of cells of various cell types in the right spatial arrangement. It's mostly muscle cells, there's fat cells, there's connective tissue formed by cells called fibroblasts. It's fairly straightforward from a tissue perspective. And so this field really is creating meat from those original cell types. This is, I should mention, not on market yet. So if you've heard anyone say they've had lab-grown meat, that's not true. They're probably referring to this, and they probably haven't had it. There have been folks who have tried this at a number of tastings or public demonstration events. I've been fortunate enough to have both duck and salmon produced in this manner. Both were delicious, very compelling. But this is not on market yet, but I think we'll probably see it start to enter high-end sort of culinary food service type of restaurants in the next year or two. So here's what that process looks like in a nutshell. You start with an isolate of cells from your target species. You can get these from an adult animal. You can get them from places like umbilical cord tissue. One company's taking that approach. So a number of different sourcing strategies. Then from there to go into full-scale production, the first stage of that is what's called cell proliferation, just getting those cells to grow and divide and form lots of cells. That's what cells do best. They take advantage of exponential replication and very quickly form a great deal of biomass. Then from there, you ask the cells to differentiate, just like they do in our body, into those final cell types. So again, muscle cells, fat cells, et cetera. And from there, any downstream processing looks exactly like meat downstream processing. At that point, you're harvesting a tissue, muscle tissue. So that's the process in a nutshell. Now, I want to end by talking about the sort of larger context for all of these different alternative protein production platforms. So, I think one of the things that really ties this field into the larger bioeconomy, which we can talk about more in our discussion in a moment, is thinking about the supply chains behind each of these new forms of meat production. And how we can think about these sort of holistically in a circular bioeconomy. So here's what I like to call the feed industry of the future. Imagine that you have any source of biomass. It could be from algae, it could be from fungi, it could be plants grown in a field, it could be seaweed grown in vast tracts of ocean farms. Or it could be side stream biomass from some other process. Say you've got a biofuels production plant or a bioethanol refinery. In that biomass, you've got all of these different types of molecular components that make perfect fodder for each of these different meat production platforms that I just talked about. So you'll have some larger proteins in that mix. Those are great inputs for things like plant-based meat. You'll have some smaller proteins, individual amino acids lying around. Those make great inputs for cultivated meat. That's exactly the perfect feedstock for those animal cells. And then you'll have a number of sort of simple sugars, more complex sugars, polysaccharide matrices that make perfect inputs for either as feedstocks for microbial fermentation or to form sort of the underlying structure and scaffold of cultivated meat. So for all of these parts that are inherently in biomass from any source, they all serve a role in these various alternative protein production platforms. So I'll kind of broaden this out to the larger bioeconomy. You know, the key takeaway here is that food is, in a very literal sense, biochemistry, right? It's the conversion of biological molecules of one form into another form. And so when we're thinking about inputs and outputs and how these supply chains will evolve over the next couple of decades, we can think about this in the context of industrial biotechnology, green chemistry, biotherapeutics, biomaterials, biofuels, and bioenergy. All of this is part of the same system of sort of interconverting between different types of biological molecules. So I'll end with one of my favorite quotes. I'll put it up first and take a moment to think if you might know who said this. If we can grow meat without the animal, why wouldn't we? You probably think it's some futurist, right? Some Elon Musk type. Winston Churchill maybe is a name rattling around in some of your heads. This was actually Tom Hayes, who was the CEO of Tyson Foods at the time that he said this. If we can grow meat without the animal, why wouldn't we? The animal is the most inconvenient part of their supply chain. So I'll end with that. Hopefully I've convinced you that maybe by 2050 we'll still eat meat, but it won't come from animals. And I'm excited to continue the conversation. Thank you all so much.
Like I said, she's going to expand your mind on that. I think you got all a little sense of what I was talking about. Matt, can you switch this up? I'm glad we did a little presentation like that. I think it was great to kind of lay it out. But what I want to do is just kind of reboot it a bit here. And the thing that kind of blows my mind about this is we're really it's only been the last 20 years, right, that we've really gotten to the point where we could even do this. And I think one of the things I was doing when I did my initial interview with you is just trying to give a sense of, like, give us a couple of the milestones that got us here in the last 20 years that has really kind of shifted the whole paradigm, essentially, of what we're doing. Because we're now essentially using biology as a tool set. I mean, biology now, essentially, we're now able to engineer cells at some level. I mean, tell us how do we get there quickly?
Yeah, there's a whole plethora of technologies that have been sort of slowly brewing behind the scenes that have now made this possible. You know, we look at something like cultivated meat. This idea has been around literally for a century and has not had any traction at all in terms of manifesting in reality until the last 5 years, 5 or 6 years. And the reason for that was sort of a whole convergence of a number of tools that were developed in pursuit of totally different fields. So, microscopy technology to be able to see what cells are actually doing when they differentiate from one type to another. Tissue engineering technology for things like organ transplantation and so forth. Biopharma to make therapeutics and so forth through large-scale cell culture. All of these seemingly unrelated things have kind of converged to make a endeavor like cultivated meat not just a philosophical thought exercise, but something that we can actually go in the lab and do and have an aim towards commercial scale. Across kind of this whole sector is really this understanding of what's going on inside cells at a cellular level. And a lot of that has to do with these tools, some of them engineering or editing tools, where you can sort of do that controlled experiment of, we knock out this gene and we see what changes in the cell, or we add this one in and we see, what gets nudged, what gets tweaked.
So in that case, CRISPR itself, which is maybe 2015 where it started to get practical, which is essentially, I mean, we had Linda Avey about a year ago here talking about the incredible collapse of pricing for cracking a human genome from about $2 billion in the first one, right around 2003, to like, what is it now, $1,000. And then there was CRISPR, which is not only can you see the cell, but or see the kind of genome, but then you can manipulate it with CRISPR.
And do so easily.
And do some easily and cheaply. And so now here at this place that it's like you say, it's really just taking off in a big way. Now, one of the ways I heard you talk about it is you said in terms of the food, you said, we stumbled around for hundreds of thousands of years hunting, just tripping over the food we could find. And then we spent 10,000 years figuring out how to slowly kind of, cultivate it as essentially farmers. And now we're domesticating the cell.
Yeah.
And literally just in the last 10 years or so. So explain that a little bit more to this lay audience a little bit.
Yeah, so, if you think about why do we eat the foods that we eat, we don't eat beef from cows because that's the most tasty meat or the most nutritious meat. It's because we happen to live next to an ancestor of cows and they were fairly friendly to humans, and so we domesticated them. And all of the breeding and sort of the integration of those foods into our culture, all of that is essentially an artifact of historical happenstance, in a sense, that those just happen to be things that we are able to farm. So now what we've done by kind of moving towards this paradigm of domesticating a cell rather than the whole organism is that we've divorced the manner of production from the biology of that whole animal. And we're actually able to start thinking much more creatively about, can we make decisions about, foods that taste best or most nutritious, or think about materials that have the right performance attributes that we can define ourselves rather than just trying to make use of what happens to be abundant in nature around us. It's really a paradigm shift.
Well, in fact, we're getting a little ahead of ourselves here, but as we're talking, you're saying, hey, within year or two, we'll have this cultured meat, which essentially will replicate that meat. But then you said to me earlier, and I just want you to maybe talk about this. You said, well, within 10 years, we'll be able to make meat a lot better. So talk about that. I mean, it's like you're kind of just inheriting this random thing we figured out.
Yeah.
But there's no reason to say that's the apex of taste or whatever. So talk about literally in the next 10 years, the future in that way.
Yeah, absolutely. I think, a lot of these meat alternative companies, whether you're talking about cultivated or plant-based, their first goal is mimicry of the types of products that we all grew up on and we know and we love and are familiar, right? That's how you sort of win over people's hearts in generation 1.0. But in generation 2.0, can we get much more creative about this? Can we think about creating combinations of things that never would have been possible? Can we have, your marbled steak that has marbling with omega-3 fatty acids? Could you drink narwhal milk? That was actually a sort of thought exercise of one of these cellular agriculture companies. Geltor, the company making collagen, they actually made mammoth jelly bears because you can find the sequence of collagen from a woolly mammoth, and you can express that just as easily as collagen from anyone, from a pig, from a cow, what have you. And so it really kind of expands our ability, very trivially, to be honest, to canvas much more widely across the biological kingdom and look for what's really the best version of whatever property I'm looking for, whatever flavor I'm looking for. Can't I just make that and not have to go on this exhaustive kind of search or go to the ends of the earth to try to find something that's really rare or that doesn't even exist?
Bacon ice cream. There we go. Well, so what you're kind of doing, and again, you're a biochemist, and you're coming out of this space. Again, we're kind of communicating to people outside that field a little bit and say, what you're really saying is really, if you break down everything around us is really made up with the same, very relatively small number of molecules, and if you just literally start with breaking everything down like that, you can just reassemble them into pretty much anything you want to do over time. I mean, is that kind of, talk a little bit about the idea that what we're able to do with this knowledge and these tools and this moment we're in, particularly in the next 30 years here.
Yeah, I mean, the beauty of biology to me is that it's actually very simple. There are a very limited number of Lego blocks, so to speak, from which you can build an extraordinary diversity of materials, foods, cells, organisms, et cetera. When you break it all down, it's the exact same sorts of structures. And so, the best bioengineer you'll ever find, the best materials scientist you'll ever find, the best drug chemist you'll ever find is time and evolution. All of these biological molecules have just been sort of brewing in a vat forever, trying out different combinations of combining, recombining different forms, different hosts, et cetera. And so, the fact that we can now be a little more directed about that and say, let's not wait another 1,000 years for, some molecule that I would find really useful in some, industrial process I'm working with to evolve naturally, or another 1,000,000 years, more like it. Can I just know the property that I'm looking for and go and design that thing using this Lego set of all these pieces?
And we're at the point now with the knowledge we're at, we pretty much can do that. Or is that something we still have to figure out?
Obviously as a scientist, I'll never say we know enough to do whatever we want. There's always more to learn. But the amount of data that some of these synthetic biology companies have amassed around different biosynthetic pathways and all the various, enzymatic ways that you can convert from one chemical to another chemical is really extraordinary. It gives you quite a toolkit. So there's always more to learn. There's always ways to improve, how efficiently can we do this? Can we actually do this at scale? Or is this the kind of thing that is really challenging and can only be done at the bench? There's still a long way to go for some of those, but in theory, anything's possible.
Which is really kind of mind-blowing. So let's look at this. The plant-based, I think you did a great job, and I think people can get that. But let's do the cultivated meat or cell-based beast. You said literally 5 years ago there were 0 companies, and now there's 35 or so.
60.
Or 60
plus. Yeah.
60 plus. We just had Memphis Meats just got $160 million in venture money, which is
doubled the amount of money in the whole space in one investment deal.
Just 2 weeks ago or something.
Yep.
So it's exploding. You're saying within 1 to 2 years we'll actually have these kind of high end, still a lot, but you see this coming down. Play out a little bit on a reasonable scenario of how you can imagine this thing playing out here in the next 10, 20 years in terms of and into adoption. And we're going to get into a little bit of that, but just what's within reach now, or what are some of the business plans now looking at from these companies?
Yeah, a lot of the cultivated meat companies are really taking a page from the playbook of someone like Impossible Foods. If some of you remember, if you were either in New York or in San Francisco in the summer of 2016, I believe, Impossible Foods launched in, I think, 4 restaurants. They were high-end. There was very much a chef-driven culinary focus around this product. And in some cases, chefs who were very, meat forward in their cuisine to show to people, if someone this discerning about the foods that they serve their clientele finds this a compelling product, then this is fair game for anyone, right? So sort of entering the market with that premium positioning, we're going to go for gold, we're going to demonstrate what this product's capable of, while behind the scenes, you're building out the supply chains, you're setting up these strategic partnerships with manufacturers and folks who know how to operationalize production at much larger scales. And then from there, you sort of trickle down into these much more sort of mainstream outlets. Now 3 years later, we see Impossible Foods in every single Burger King in the country, for instance. And so I think that's very much the strategy for a lot of these products, knowing that they'll enter the market at a price premium, no doubt, but kind of capitalizing on that to generate enthusiasm and to generate demand and awareness and really get that visibility while you build out, large-scale production in the background.
Which is really kind of, it's not just impossible. It's like the Tesla model too. Make the really coolest thing that everyone wants, and then scale it down. Scale it up. So that's the strategy. But you and I had been gaming again because of this crazy story I'm trying to figure out in the next 30 years and how these things play out. You say some estimates from a think tank point of view could imagine that we could scale up to all meat essentially cell-based by 2050. That's pretty ambitious compared to others, but they're talking 40% and 20, 30, 40s. I mean, they're gaming this out pretty aggressively. So can you talk a little bit more about that and like the credible kind of projections on this?
Yeah, so there's a number of market projections from reputable analysts who are looking at large-scale trends here. The most pessimistic of those, I think, typically put alternative proteins at ballpark of 10% of the global meat market in the next, say, 10, 15 years. That's an extraordinarily fast rate of change in an industry as massive as the food industry. There's so much capital infrastructure kind of embedded momentum or inertia in the food industry right now. But to get that fraction of market share is really quite extraordinary. Just to give a sense of perspective, the global food industry, or the global meat industry, excuse me, right now is about $1.5 trillion industry. Which is mind-blowing for people in other fields. So to get that level of penetration as sort of the bottom of the mark, and then folks looking at somewhat more optimistically or more aggressive penetration, some folks are saying that 50% of our total protein consumption, or rather a drop-in replacement for meat, eggs, and dairy, could be coming from these alternative sources maybe by 2040. And there is that one think tank report that you're referring to from our prior conversation. There's a group called Rethink X, based partly out of San Francisco, partly out of the UK, that put out a fascinating report looking at some of the sort of feed-forward dynamics when you start to displace some of the aspects of the value chain and essentially the side streams of the animal agriculture industry. Let's take the cow, for instance. This is sort of what they argue, and I agree, is sort of the most vulnerable of these various animal agriculture industries, in part because of that inefficiency we talked about earlier, 3% conversion rate. But think about everything coming out of a cow when a cow's slaughtered. There's some really high-end cuts of meat. You've got your T-bone steaks and your ribeyes and your sirloins. I'm not a meat eater, so I don't know what the most prized cuts are. But you get a handful of those. Then you get a boatload of ground beef that is pretty low value, but we've sort of, over generations and centuries, kind of instantiated in our culture to have food products like burgers and so forth that kind of elevate and valorize that ground meat. And then you've got a whole bunch of organ tissue and bones and hide and all of these side streams that, again, we've found ways to make use of them. We've found ways to eke little bits of value out of them. But as soon as you offer people a higher performing, similar or lower cost alternative to any of those side streams, suddenly you're chipping away at people's ability to valorize that whole animal or to justify, rearing and slaughtering that whole animal. And so you don't need one-for-one displacement of all of these products to come to fruition in order to topple an industry like that. And so that's really this one group's point here, is that once you get to parity from a taste perspective and a cost perspective on a couple of these products, say it's milk products, which we've already seen tremendous uptake in the market, and ground beef products, which again we see Impossible Foods and Beyond Meat really capturing market share there. Once you've got a couple of those sort of key legs of the stool, does the whole thing go under?
Well, we've certainly seen that happen in other industries the last 25 years with the IT world. And the energy world, we're watching it with solar and others. So yes, it's fascinating. It's happening in the same, there's so many of the patterns are kind of crossing across these industries. Drivers of this, now you haven't really talked about the climate change side of this, but how much do you think, people talking about methane release from cows, and how much do you think this is also going to be accelerated by the climate change pressures, actually?
Yeah, it's a great question. I think certainly that is top of mind for a lot of consumers. I do think that's what's driving a fair bit of the interest in this space. So to that extent, that's helping this. I think honestly, it's not dependent on some of these concerns around climate change. I think what's really driving this is the economics of it. Ultimately, I think you've got this new, fundamentally more efficient production paradigm, and that the folks moving in this direction, including these meat companies that are launching products in this line, they're not doing so because they want to feel warm and fuzzy about the planet. It's because they see the writing on the wall from an economic perspective.
Well, no, I live in Berkeley. I work here in San Francisco, and you can't even say GMO in Berkeley without getting piled on. What do you make of the social and cultural acceptance of this? You and I have kind of deconstructed what went wrong with the GMO thing, but it's a similar thing in which it's a scientific application of a thing that all of a sudden got all this backlash. Now, maybe we should just talk about that. What do you think went wrong with GMOs that you think could be done differently and that the meat industry is doing differently now? And then talk a little bit about the acceptance side of things.
Yeah. So I think the GMO parallel is apt. I think this field has certainly taken a lot of lessons learned, really from a communication standpoint, because I think that's really where the breakdown was with consumers was around a lack of transparency. There were a lot of factors here, admittedly. There was a lot of I think, anger towards certain business practices that then got conflated with a technology. So that's always kind of a challenge to make sure people are clear about what's a technology, what's sort of the way that technology has been, manifested.
So genetically engineered food is the technology, but the business practice was to make a much more efficient production side of things and profit rather than any kind of benefit for the consumers. Is that what you're getting at?
I think a lot of the benefits of that first generation of GMOs really accrued to the farmers and the producers, and consumers didn't see that side of it. Now I think there's been a lot more discussion around how can we use these genetic tools to develop crops, for instance, or a whole host of other things that either benefit the consumer, so things like the non-browning apple, for instance. That's a great convenient thing to have in my fridge. I cut an apple, I leave it uncovered, and it doesn't brown. Or to do really, really sort of fundamentally good things for the world, like curing micronutrient deficiencies or creating drought-tolerant or salinity-tolerant crops that are much more robust to some of these climate challenges. So, I do think there's a little bit of shifting perception of who can these technologies benefit. But I think the big thing, and one that this industry is really taking to heart, is around transparency with consumers. I think for the original kind of wave of GMOs, there was a sense that this was being done sort of behind the scenes and slipped into our food supply, rather than being very upfront with consumers and trying to explain it to them and explain benefits in terms that they would resonate with. And so what I see that's really different in the cultivated meat space is embracing that transparency and saying, here's an opportunity where we can actually literally show people how the sausage is made in a way that you wouldn't never think to do in the animal meat industry. We're not inviting people in for tours of slaughterhouses. And yet, just a couple weeks ago, actually, Aleph Farms, which is one of the cultivated meat companies in Israel, just announced that they're opening a visitor center for them to be able to bring people in and show them the process. And be truly transparent. And again, this is before these products are even on market. So really starting that conversation early and tapping into what's important to consumers, which is increasingly authenticity, transparency, et cetera. So building that trust.
Now we're going to open it up shortly here. So think about ways you might ask questions from the audience. But let's broaden it a little bit here. So that same process we described, start with the basic, molecules and build the right meat and even a better meat. We can do that with materials. We can do it with all kinds of things. So talk to me. I think a good example you've talked about before with me is plastics. I mean, here we've got plastics. They takes 1,000 years to biodegrade. Our oceans are filled with them. The fish are, the whole thing. I mean, could we just use these same techniques to essentially do biodegradable, plastic, all kinds of containers and all kinds of stuff? So talk a little bit about that.
Yeah, absolutely. So it is something that I think a lot of people don't necessarily recognize or appreciate at first blush is that petroleum is bio-based. I mean, petroleum is the long, compressed, heated skeletons, essentially, of ocean plants, aquatic plants. And so anything that comes from petroleum, whether it's the fuel itself being replaced by biofuels, or this whole plethora of all of the other side streams of petroleum refining, which is adhesives and plastics and a whole slew of things, paints, et cetera. These are all bio-based materials. They are fundamentally. And so the endeavor now is just to say, how do we produce them in this form straight from the organism rather than needing several million years of compression and heat under the Earth's crust to get this form?
So, for example, we could devise a material saying that when the container would be exposed to seawater or sunlight, it would biodegrade within 10, some amount of time. And there'd be these conditions that we know there's materials that do that. We know the forests do that. We know leaves do that. There's ways to just engineer that right into our packaging. Is that fair enough to say? Are we there to do that, or is that something someday we'll be able to do that?
We are. We're getting there. So right now, a lot of those materials exist. They tend to be at a little higher price point, which I think is why we haven't seen them quite as pervasively in the products that we're buying every day. But take like the PLA compostable cups that you see at events now. You see those all over the place. That's a bio-based plastic that is compostable. So it's the same sort of phenomenon there. I'll just highlight one company that I find super cool that also has a nice story of moving from the material space into the food space, which is a company in upstate New York called Ecovative, like innovative but eco. They use fungal mycelium, basically the root structure of fungi, to grow essentially biostyrofoam. And the cool thing is they can grow it exactly in the shape of the product that you want to ship. You just stick a mold on your growing mat of mycelium, and then it forms that shape. And then you harvest your mycelium, you stick it in a box, and you put your product in there. Totally biodegradable. That company now has just spun out a daughter company, I guess, called At Last Food Co. That's using that same paradigm of growing fungal mycelium, fungal root tissue, and you have very exquisite control over the density of that tissue and the branch structure of that tissue and so forth, and you can really recapitulate a fibrous kind of meaty-like structure. They're also starting with a bacon-like prototype.
Another bacon.
Yeah.
Different.
So again, just to highlight, materials and food, like we think of these as totally different things, but.
Well, you've reminded me, and I think it's worth reminding everyone, it's like, when you really think about it, we're surrounded by biological products. We're wearing cotton clothes, our homes are wood, we're eating food. I mean, pretty much our experience of life is using these products that up until now have been, we go find them in nature and we kind of pare them down and carve them or try to do things to them to kind of make them work for us. Mm-hmm. And pretty much everything that fits that now could be precisely engineered with minimum waste, with maximum attributes to make the best possible things that the human ingenuity can just come up with. Is that fair enough to say?
Absolutely, yeah.
I mean, it's kind of mind-blowing. What do you think about it?
Yeah, we've been scavengers for so long, and now we're suddenly in the driver's seat in a way that's totally not like, playing God creepy. It just is. We just know enough about these systems to be able to be much more directed and intentional about how we use, materials around us.
So when you think of the big picture, again, 2050, even maybe longer, 2100, if we're looking back on here, I mean, do you see this biological engineering or biotech revolution, or however we want to phrase it, synthetic biology revolution is as fundamental as the Industrial Revolution. I mean, we're really in a complete paradigm shift, that this century will essentially rebuild everything almost along biological directed pathways, the way you've been describing. Is that your vision? And
I do think so, yeah. And I do think, you know, to go back to how you sort of opened our session this evening around, you know, the digital revolution and all of that, I think, you know, this really builds off of all of these prior sort of leaps in innovation. I don't think we would be able to do even a fraction of what's happening in the bio-revolution right now without all of this foundation of data, so that we have all of these genomic insights, we have all of these technologies to, you know, screen really rapidly through a million different varieties of something to find just the one we want. So it really is a, you know, a self-perpetuating, self-fulfilling kind of cycle towards a future that I think will look very different. And I'm admittedly a techno-optimist, but it's one that I'm really excited about. I think it really paves the way to you know, have a much lighter footprint, but one that actually serves us much better. So, you know, lessening our impact without sacrifice at all. In fact, much the contrary.
Well, I am an optimist as well. I share your optimism, but maybe not everyone does. So let's turn it over to folks here in the audience, and we've got one mic runner here. And all right, here, why don't we start here, and we'll kind of move it around. But look, are people who, could I see hands from people just so we can kind of work it around here? I'll think about this. Okay, and stand up, please, and just introduce yourself. We're doing this on video.
Thank you very much. That was really fascinating. My name is Greg DeLon. I'm with the Urban Innovation Exchange and also now with the Deep Blue Institute. We're focused on regenerative marine infrastructure. So I saw you had 29% land and 71% ocean.
Yeah.
I'm curious with what's going on. What do you see there? I realize that's not what you're focused on for your presentation, but you know, with macroalgae, microalgae, and then fish, flesh, all that, is there some big opportunities there, or is it really just another version of what you talked about here, and it's just a different source of raw materials?
That is a great question, and I'm thrilled that you asked it. I have the word seafood in all caps on my notes sheet here to talk about this, because I do think it's underappreciated in the food space as a whole, but in the alternative protein space. You know, the sea is the source of a huge fraction of the global protein consumption, animal protein consumption, particularly in other countries and in developing nations. You know, I'll start with one sort of observation, which is that a lot of the intensive animal agriculture on land has been, to a huge extent, accelerating the trauma inflicted on ocean ecosystems. A lot of that, you know, effluent, eutrophication, ocean dead zones, et cetera, is really exacerbated by what we're doing on land. So they are very much intertwined. And the ocean, you know, arguably to the detriment in that relationship. But I think seafood is such an opportunity area for these alternative protein production platforms. You know, there's obviously consumer concerns that are unique in that category around, you know, contaminants and everything from mercury to PCBs and overfishing and so forth. But from a totally selfish kind of consumer perspective, there are a lot of ocean species that we enjoy eating that you pragmatically just can't aquaculture. You know, that's what our ocean, our seafood consumption has been shifting more and more towards aquaculture, where in the land we're kind of at where we were probably a few thousand years ago. Sorry, in the ocean, we're at where we were a few thousand years ago on land in terms of the ratio between farmed animal consumption and wild-caught or hunted or harvested animal consumption. Right now we're hunting half of our sea life and farming the other half, and it's going very quickly towards farming. I wish I had a chart up here, because it looks like these hockey stick curves I've been showing for everything else, the increasing share of our seafood that's coming from aquaculture. And so, you know, if you think of the number of land animals that we eat, 90% of it's about 6 different species, right? It's cow, pig, chicken, duck, goat, right? We used to eat dozens, hundreds, right? And probably a lot of them tasted better than these. Again, these just were the ones that farmed the easiest. In the ocean, think how many wild fish species we eat, or crustaceans, or what have you. When you look at farmed fish populations, they're almost all tilapia, carp, really kind of boring from a culinary perspective, if I'm being honest, types of fish. And so to take something like cultivated seafood, growing it from cell culture, this is really, I would argue, our last chance at being able to eat something like bluefin tuna 50 years from now. There is no way to aquaculture bluefin tuna, pragmatically. And so once we fish them all, or some other pressure that the ocean's under, whether it's acidification from climate change or whatnot, we otherwise may very well be saying goodbye to a lot of those species.
But what you're saying with the cell-based culture, you could just do the same exact thing with the tuna that you could do with anything. I mean, there's no differentiation.
There will be subtle differences. Different species prefer slightly different temperatures, slightly different, nutrients in their culture media, et cetera. But, from the perspective of 90%, 95% of your infrastructure and your process and your inputs, you could just as easily make a salmon fillet or a bluefin tuna fillet or a carp fillet, if people eat such a thing.
I also just want to make clear, if you made out to me, if you take the cell from the animal can live, the fish can live, right? I mean, you're not even killing them, right?
Yeah, you don't have to. Yeah.
And so it's an extraordinary thing from the animal's point of view or the fish's point of view.
Yeah.
Like 50 years from now, we wouldn't have to kill anything.
Yeah. Yeah, and I think
it's a kind of a trippy way to think of it.
Yeah, and I didn't bring up the animal welfare consideration of all of this, but it's a massive one. It's hard to overstate the level of sort of tragedy from a suffering perspective, both in the ocean and on land. Yeah.
Okay, we had back here. No, right. I was going to right here. Yeah, John there. Yeah. Can I see hands over this way? I just want to kind of get a sense who are moving around here for different people. Okay.
So my name is John Kao. Thank you very much for the presentation. I'm curious to hear some more thoughts from you about the potential impact of this area of innovation on public health. We're in this epidemic of obesity, which is partly caused by eating animal products and, cardiovascular disease and so forth and so on. You kind of teased us with that omega-3 marbling example. But I would imagine that the boundary between food and, what I guess people are calling popularly nutraceuticals is now getting kind of blurry. And I wonder if there's a way to shift consumption patterns towards greater public health.
Yeah, absolutely. And I'm glad you brought that sort of chronic public health sort of dietary aspect up, rather than just sort of the infectious disease or antibiotic lens on that. I think, our history of better understanding foods and the extent to which they sort of drive our cravings or activate other, various sort of pathways from our history that maybe aren't so useful anymore. I think we tend to think of how that's been exploited by food companies, right? Making things that are so, we just can't put that bag of chips down, or so enriched for fat or sugar, far beyond what we sort of evolved to handle. But I do think there's a paradigm in which we can use that in the other direction. Can we understand food well enough and understand what's actually activating what receptors, both in our mouth and in our gut, because you do have, virtually, essentially taste buds in your gut as well, that are telling your gallbladder, for instance, which bile enzymes to make based on the composition of the meal you just ate. Can we use those insights to actually make the healthiest types of foods possible also be the ones that taste the best, And we have examples of this at a fairly crude level. We've bred all sorts of crops to no longer be as bitter as they used to be, for example. I've been having this conversation about Brussels sprouts a lot lately, because a lot of people remember Brussels sprouts from their childhood, I guess, as being extraordinarily bitter and just awful. And now they're kind of back in vogue, and people are serving them at restaurants with bacon crumbles on them and all of that, which is a perversion of its its own right. People are like, wow, they really are tasting better these days. Am I imagining that? No, you're not imagining that. Some guy in the Netherlands, I think, has been breeding them for 20 years to try to get them less bitter. Because now you know exactly which molecules in them are bitter. You go and find, the alkaloids and the saponins and so forth, and you find the synthetic pathways for those in the plant, and you find a strain that doesn't have them. Either you engineer them out, or you just breed and breed and breed until you get rid of them. So I think we have a real opportunity to go the other direction with food and say, can we treat ourselves best and also truly enjoy that experience of eating?
Can we just get this woman here in the middle? Emma? Oop. Oh, yeah, there she is. Yeah, go ahead. Right here. Or is there someone back there, too?
Right in the middle.
Yeah, right in the middle there. Let's.
So it's great to hear that, because I had a question similar to that some people
Could you just introduce yourself?
Oh, yeah. Hi. Dipti Desai. I work for an organization called US-India Strategic Partnership Forum. And it's interesting, in India, we have a lot of vegetarians, and both McDonald's and Burger King exist in India, but they would serve the veggie patty there, but the meat lobby in this country prevented you from serving vegetarian burgers that tasted good. So I'm glad that there's an alternative now. But I just wanted to say, some people eat to live, some people live to eat, right?
Yeah.
Do you see the world moving to a direction, and this goes back to that question, where you just pop the right pill for yourself that takes care of all of your nutritional needs? Because many of us don't have time to eat, and when we do, we end up eating unhealthy. Or even go out into the sun and stand out and photosynthesize the food ourselves. So is there migration towards that? And I'm really, really happy to see more plant-based alternatives over here that are tastier and are impacting the world, and especially when so many technology companies are going to zero carbon emissions, and they're mentioning that every day I hear Amazon and Microsoft and others saying that maybe food is probably the highest impact of carbon emissions that any industry has.
Yeah, absolutely. I think the question, will we all just be eating Soylent for the rest of our lives, right? I honestly don't think so. I think there is, such a genuine sort of human enjoyment of food, and the fact that it serves such a crucial sort of social role in our lives and in our communities. I don't see that experience ever going away. And honestly, I think, a lot of these technologies sort of democratize food production in a way. You can get, clever and creative in the kitchen or in restaurants that you go to, when you've got sort of this abundance of creative materials to work with, essentially, that I think will keep that part of our culture. I do think that, the sort of Soylent move, there's a time and a place for that. If you're running around the office between phone calls and you just need to down something so you can keep walking, go for it. But I don't think we'll lose this sort of innate aspect of our society or our enjoyment. Yeah.
You also just you had mentioned to me that you think by 2050, even if you would get kind of meat not happening, it would still be like, we don't use horses for transportation, but we still have them for hobbies and stuff. You feel that there is a place for this kind of animal husbandry for a while.
It wouldn't surprise me if it does become this sort of cottage industry, almost recreational sort of thing, that you might still have small-scale farmers just for very sort of select, I guess, high-end markets, I would assume, at that point. It also wouldn't necessarily surprise me if there's sort of a wholesale societal shift away from normalizing the act of eating animals if we then become very turned off to that concept as a whole, and might want to see stronger protections put in place to ensure that it's not still going on even at small scale or high welfare kind of facilities.
Or maybe it's a total backlash. Do you think it's possible that people could backlash against this and just say, no, I want my steak or whatever it is?
I think some people will do that. I don't know how many of those people will still be around in 2050.
Okay.
If I'm being frank.
All right, here, let's go right here. Could you just stand up and introduce yourself?
Hi, Gwen Cheney. I'm actually a Symbiosis seed investor. So I've looked at a bunch of companies. What I struggle with, a lot of them are great ideas, like the economic or the environmental plays. What I struggle with is the economic viability, that it's not, if something isn't going to be viable, even in the next 5 years, it becomes very difficult to invest in it. Any advice on that?
Yeah, it's a great question, and I do think there are some cases where some of these technologies have made a leap into the commercial sector in the form of these startups at probably a slightly younger maturity level than it would have behooved them to do. Often you'll get sort of foundational academic research going on for these new technologies until they're at technology readiness level, 2, 3, 4, if anyone's familiar with that sort of engineering framing of technology, and then they'll move into the commercial sector, and that's really to get a grip on scale up and moving that into an industrial production context. I do think some of these companies have made that leap at slightly younger maturity levels, and so I do think that's potentially challenging if you're in the sort of traditional venture capital boat of kind of, classic time horizon of those types of funds can be challenging. I do think what we've seen that's been helpful to this space, and I think is a good sort of risk mitigator for these types of situations, is early involvement of kind of two very different categories of investors coming to the table. On the one hand, mission investors, or at least folks who have a double bottom line. So they may have, a sustainability angle to what they invest in. They may have a slightly longer time horizon. They may have a 15-year fund rather than 7 or 10-year. And then on the other hand, strategic investors from these larger corporate entities. And so those are the folks who are sort of your I don't want to call them safety net, because obviously it's not guaranteed, but they're in this because they potentially have an interest in acquiring, right? And so that might be the time frame for those types of activities, even if that's in advance of break even from a cost of production point of view.
Okay, and then
Arvind Sankaran, work for Plenty, indoor vertical farming company.
Yeah.
So for the cell-engineered companies like Memphis Meats, do you envision any roadblocks from FDA or other governmental regulation? And second part of the question is, in general, do you see potential downsides for all three of those technologies that you were presenting, and what we, me being in the same industry, should watch out for?
Yeah.
could you just explain Plenty for people who don't know?
Plenty is a startup in South San Francisco. It does indoor vertical farming, and we sell in stores, Whole Foods and other places in San Francisco. We make leafy greens for the moment.
Nice. Yeah, I'm glad the regulatory question came up, because this is always a big sort of looming unknown, or at least has been for a while for the cultivated meat industry, but less so now. So we've seen quite a bit of movement on behalf of regulatory agencies actually working together, surprisingly, to figure out what the path for regulatory approval looks like for cultivated meat. And obviously there's pretty big differences from country to country what those processes and paths look like. In some cases it's really well established. So in Europe, for example, they have a novel food designation that specifically includes animal cell culture derived products. So it's pretty clear that's the path we follow. It's pretty well outlined. In the US, for the first couple of years of this industry, people were a little bit on pins and needles, because it wasn't even clear which agency had jurisdictional authority to regulate this product, because Food and Drug Administration regulates most foods, and everything produced in cell culture, whether that's a drug or a food product, But the U.S. Department of Agriculture regulates meat and oversees meat inspection and meat slaughter and meat labeling. So this was really kind of a head scratcher for these agencies for a couple of years. And then in the last year or so, they've actually established together a joint regulatory framework where they both have partial oversight over the process and in a way that actually correlates really nicely with their respective expertise. So the Food and Drug Administration will take ownership of pre-market approval and up until the point of harvest from your cultivator tank. And then after that point, USDA takes over because at that point it's arguably just meat. And so they have jurisdiction over inspection from that point onward in terms of production facilities and so forth. So at least we have that much information about the process. None of the companies have gone through the process yet, and so there's still quite a bit that remains to be worked out in terms of what exactly this looks like as it manifests. The final thing I'll mention on the regulatory perspective is there are quite a few countries that have been very proactive about saying we want to work with this emerging industry and be actual partners in kind of seeing this through, making sure we have very rigorous, kind of comfort with the process and with consumer safety. Singapore has been really leading in this front, and they're coming at this from a food security perspective, right? They import something like 94% of their food calories, and they have immense biotechnology expertise. They do a lot of biopharma manufacturing and so forth. So yeah, we've seen, I think, differing levels of sort of enthusiasm or engagement among regulators, but I'm optimistic. I mean, a lot of this is you can utilize the same types of hazard analysis frameworks and monitoring strategies and risk mitigation that's been pioneered for a long time in the food industry here.
Now he asked a two for which, but I think let's ask that second one though. He was talking about the downsides. We have been very optimistic. We're both kind of very optimistic. But I'd be curious, even out there, of how people perceive this. But what do you see as potential downsides that people should brace for or worry about a little bit?
Yeah, it's a great question. The unknown unknowns, right? What do we not know? We don't know. I think one of the things that keeps me up at night a little bit is making sure that we are kind of forecasting what these new production methods will need and when they'll need it. I mean, what a tragedy would it be if 10 years from now we're on this up and up trend of market penetration of these and then we realize, like, my God, we've run out of plant-based sources of saturated fats. So what are we going to make all our Impossible Burgers with? So, having an eye towards where might those bottlenecks arise and what types of solutions should we be sort of seeding today in fundamental research to make sure that those aren't handicaps or that those kind of crunches don't cause unanticipated consequences, like we're deforesting to grow more coconut trees or whatever for Impossible Foods. So I do think we need to be clever about that. I do also think, going back to this notion of disrupting an industry by sort of chipping away at it, death by a thousand cuts sort of thing. It is true just by virtue of the fact that the livestock and meat and animal ag industries have had hundreds of years to sort of evolve alongside all of these other industries that do take those various side streams, that if we disrupt this very quickly, we may actually go through a period where there's quite a bit of inefficiency because now we've got demand for some products, but very little demand for some of the sort of necessary co-products of those. And so, again, to the extent that we can sort of model this out and forecast and be able to anticipate, like, what are going to be these gluts of materials that are going to be very low value, and we need to find some way to valorize or at least not be wasteful in the short term as this kind of readjusts to the new normal, this new paradigm.
Okay, gosh, there's so many questions here. Okay, let's try it here. You've had your hand up for a little bit. We only have the last few questions here, and then we're going to go. and be able to chat and have drinks and actually eat more of this great food. Go ahead.
Yeah, just wondering that Warren Linney from the Climate Restoration Circle here in the Bay Area. Carbon footprint of these synbiol type of products versus, the cattle industry, for example, and maybe you've seen the Alan Savory's TED Talks, that maybe moving cattle around and the compost they create and so forth is some way of actually, drawing down carbon into the soil. And then also the health aspect. These products are now, not right now required to be tested on humans, before they go to market. And what do we anticipate might be some problems? Obviously, it's around a lot of locations right now, so probably getting a lot of data. But have you seen any studies on that?
And you're talking about plant-based meat for that second question there? Yeah.
Exactly.
So on the climate question, there have been a handful of life cycle assessment studies that have been done for plant-based meat products. Beyond Meat, in particular, had one commissioned, or didn't commission it. They had a University of Michigan researcher do a life cycle assessment on their product. And the numbers from a greenhouse gas emissions perspective, from a land use perspective, from a water use perspective, were essentially order of magnitude reduction, in some cases more than that, so 90+% reduction on all of those, which makes sense, right? If you're looking at that feed conversion ratio for a cow, you're having to grow all those crops, even if they're grass fed, that's an enormous land requirement, right? For the cultivated meat products, there have been about a half dozen hypothetical life cycle assessments, because none of these are at full-scale production yet, so you can't actually, go and read the actual, energy usage on the cultivators and so forth. But taking numbers from parallel fields that do animal cell culture for other applications. And across the board, those also are anticipating order of magnitude or more reductions in land use, in water use, and in greenhouse gas emissions. A lot of that as a result of essentially eliminating methane associated with enteric fermentation in ruminant animals. The one metric that they're less in alignment on is total energy usage, and those discrepancies really have to do with some of the kind of process assumptions that they're making about how, do you steam sterilize the reactors, and a lot of details that I'd be happy to get into with you one-on-one. But I think the land use change, overall greenhouse gas emissions, water use for all of these products it looks very favorable from all of the analyses that I've seen. And to get to your sort of, grass-fed land use sort of argument, I think a lot of folks would be in agreement that the best use of land from a climate perspective is to let it go fallow and rewild, right? And then you've got ruminant animals, circulating on it. We used to have, millions of buffalo in this country that were serving that role, and we hunted them all. And now, that's sometimes seen as a climate perk to have, manure fertilizers being dropped on some of these, what used to be enormous prairie lands and so forth, and have now become quite deserted. But we can go back to that in a rewilding sense without having to sort of rely on an industry like the livestock industry to do that for us.
Well, I'll tell you what, we've kind of run out of time here on this live stream and the 90 minutes here, but here's the deal. We have the bar still open. We've got the food there. She's happy to talk, and I think what we got to do now is give her a fantastic thanks for expanding our brains on a very complicated issue.
Thank you.
Really fantastic. Thanks, and again, stay around, talk to your peers, and let's keep the conversation going.